So happy 3210. Yeah, that was a good start. Oh, and happy birthday. All right. Uh, okay, on a much more serious note, geometric sequences. So arithmetic sequences have a common difference. You're adding the same number each time, and sometimes that number could be negative, so it's kind of like you're subtracting the same number each time. Geometric sequences have a common multiplier or ratio. Okay, so for example, I might have the geometric sequence 1, 2, 4, 8. I'll make it infinite, so I'll say comma dot dot dot. Goes on forever. So to go from 1 to 2, I multiply by 2. 2 times 2 is 4. 4 times 2 is 8. I have a common multiplier, and we call that R. So I'll say R equals 2. Okay. Common multiplier or ratio. So I call this common multiplier R, so I might want to call it the ratio instead. All right, I'll give you another geometric sequence. Common multiplier or common ratio are the two terms that are used for this. And we abbreviate it with R, so call it the ratio. That way it starts with R. So I'll give you another geometric sequence. 3, 1, 1/3, 1/9, 1/27. What number am I multiplying to go from term to term to term to term? Yes, Catherine? We're dividing by 3. And so I need this in a multiplying fashion. So dividing by 3 is the same thing as multiplying by the reciprocal. So I'm multiplying by 1/3. Okay, so my common ratio is 1/3. Give you one more example. 6, -24, 96, -384. Now, let me try to find the common multiplier. I think I know what it is, but let me just, if you're having a little hard time finding these multipliers, then here's a method for doing it. If I have a geometric sequence, then any number in the sequence times that R, that ratio, has to equal the next number. So I'll go 6 times R equals -24. Divide by 6, and that common ratio is -4. Now I could verify for the rest of my sequences. If I'm trying to figure out if this is a geometric sequence, then let me verify. Is -24 times that -4, is that +96? Yeah, I have a geometric sequence. Okay? The formula, the explicit formula, we won't do the recursive formula, is, I call it A sub n equals A sub 1 times R to the n minus 1. Okay, so for the very first sequence I gave you, my formula is A sub 1, that's 1, times R to the n minus 1. So that's 1 times 2 to the n minus 1. I'm going to clean that up. I don't have to make 1 times anything. And just call this 2 to the n minus 1. Yeah, I'm going down to show it to you again. I had to, there you go. There's your formula. Okay. A sub n equals 2 to the n minus 1.
So, like, would it be 1 times 2 and then that to the 2 minus 1?
No. Exponents are always done before multiplications.
Can you show us the
Okay? A sub n equals a sub 1 times r to the n minus 1. Do the exponent first, then multiply last. Okay? So let's try to find, we had the 4 numbers here. Let's try to find the 6th number of this sequence. A sub 6. That's going to be 2 to the 6 minus 1, which is 2 to the 5th. What's 2 to the 5th? Anybody know? 32. Okay. Second sequence that I gave you. Let's find the formula for that. Maybe I'll write that in a different color. A sub n equals a sub 1, oh, that's 3, times multiplier 1/3 to the n minus 1. If I have negatives or fractions, I better put that r in parentheses. So let's verify that a sub 3 is 1/3. A sub 3 is 3 times 1/3 to the 3 minus 1. That's 3 times 1/3 squared, which is 3 times 1/9, which is 3/9, which is 1/3, just like it was supposed to be. And then for the last one, my formula a sub n is 6, a sub 1, times the ratio, -4, all in parentheses, to the n minus 1. So I'll verify a sub 2 should be 6 times -4 to the 2 minus 1. Oh, that's 6 times -4 to the first power. Oh, that's -24. Yeah, that's what it was. Okay. Now, just like we did arithmetic mean, we're going to do geometric mean. So the geometric mean of any two numbers, let's say x and y, is the square root of x times y. And that geometric mean will get me the number in between two numbers in a geometric sequence. So if I have a geometric sequence that's got, let's say it's 5, and then, I don't know, and then 100. That number in the middle is